Okay, so here's another part of your study guide. So this is, I want you to do the major layers, which we've already talked about, the theory of continental drift, and then the theory of plate tectonics, evidence behind it. Obviously, we've just gone through the evidence. Now, I've done already a whole movie, and I put the same movie up last week as I put up this week. It's just the three kinds of plate boundaries, and that was the other question, the other essay question. You're supposed to draw cartoons, list the three types of plate boundaries, and say what happens at each. So when I mean say what happens at each, like in a divergent plate boundary, the plates are spreading apart and new seafloor is formed, and list a example, so Mid-Atlantic Ridge, right? And at a convergent plate boundary, what happens? The two plates come together, one plate subducts under the other. An example would be the Nazca Plate subducting under the South American Plate. The Peru-Chile trench is there, so you get trenches forming, and big active volcanoes and earthquakes happen a lot. And then in a transform, the two plates are sliding past, and there's earthquakes are there, but nothing's created, nothing's destroyed, and an example of that would be San Andreas. So there's a whole other movie on that, the three types of plate boundaries, and you should know what a hotspot is, and I'll go over that. But I'm not going to go over these three types because there's a whole nother movie on that. I will mention this one because this was on your pieces of evidence, the distribution of earthquakes, and you can see here they're shallow on the divergent plate boundaries. They're shallow earthquakes, the spreading centers, the divergent plate boundaries, and shallow earthquakes and transform fault. But when you get convergent plate boundaries, two plates coming together, and you get subduction, you have shallow, medium, deep, shallow, medium, deep, shallow, medium, deep, shallow, medium, deep in the direction that the plate is subducting under. And that's a really strong piece of evidence for plate tectonics, and the idea no one's been down in a subduction zone. No one's been down there, but it's nevertheless, this information is very, very strong evidence. And here you see another shallow, medium, deep. So remember, I was saying on that essay question, I do want you to be able to give examples. So you're going to list what happens at each, or draw the cartoon, say what happens, and give examples. Okay, so then in the last couple weeks we've talked about continental margins. Remember last time we talked about active and passive, continental shelf, continental slope, and then all these things on the ocean basins. You should be able to kind of know what these things are, use it in sentences, ID them in multiple choice or true false, and point to them. So ridges, what's a hydrothermal vent? Trenches, canyons, abyssal plains and hills, seamounts and guyots. So I'll just kind of go over this with you. Oh, we talked about the ridges like crazy. Those are the places on the seafloor where the divergent plate boundary, it's an undersea mountain range where the two plates are separating. And in the middle of the tops of the ridges where the new seafloor is forming, if you take a submarine down there, you'll see hydrothermal vent, which is like an underwater hot spring or an underwater volcano where the lava is just kind of coming up and the hot springs are coming out. And we'll look at them much more. Trenches are places where subduction is occurring, and you get a mountain range on one side and a very deep trench on the other. Trenches, of course, the deepest part of the ocean. Canyons, on the other hand, are part of the continental margin, that it's kind of like a undersea rock slide or an undersea mudslide creates a canyon on a continental margin. And abyssal plains are those places in the ocean that are just flat. And of course, there's not that many, but there are some areas of the ocean that are like the abyss, just flat. And then an abyssal hill is like just a little bit of a hill. It's not like a mountain. Seamounts, remember, is the difference between a seamount and an island is that in the case of an island, the island comes out of the water, the top of the island, and a seamount is an undersea mountain that does not come out of the water, and a guyot is an undersea mountain with a flat top. So here's your continental margins, this kind of greenish color that are around the continents, and they're the submerged part of the continent, the part of the continent that's underwater. So, and this light part is deep ocean, continent, and continental margin. And you've got, so here's your continent, here's your deep ocean. This area right here is your continental margin, continental shelf, continental slope, continental rise. And here's a view of it. So here's the deep ocean, the Pacific Ocean over here. Here's California, the land, and this white area, the continental margin. So part of the continent that's underwater. You can see right here, where I'm tracing, is the edge of the continent. Not the edge of the land, the edge of the continent, where the continent ends and then it drops off steeply. You can see there's a canyon here, there's a canyon here, there's a canyon here. So canyons cut into the continental margin and rivers make them just like rivers make them on land. So the difference between passive margin and an active margin, so this would be like a good short answer. Active margins, the continental margin is right at the plate boundary. They're active because there's a lot of activity, a lot of earthquakes, a lot of volcanoes, and they're mostly around the Pacific, right? And they're very narrow and very steep. Passive margins, the continental margin, where the continent is a little bit underwater here, and you can see it here, is far away from the edge of the plate. So here's the continental margin, here's the edge of the plate. That's like 2,000 miles far away. So a continental, passive continental margin is passive. There's not earthquakes and volcanoes there and big mountains or anything. And they're very broad and very shallow, broad and shallow, mostly in the Atlantic. So you can see them here. Here's your active continental margin, active continental margin, passive continental margin, passive continental margin. The edge of the continent is far away from the edge of the plate. Edge of the continent is right on the edge of the plate. So, you know, this would be a good thing right here to just like pause and go ahead and study some of the names of the plates and, you know, your divergent plate boundaries, maybe know one or two or three, and your convergent plate boundaries and your subduction and where your trenches are, and, you know, where we talked mostly about Hawaii as a hot spot, but, you know, this would be a good slide to just kind of study. Here's your African rift zone where these two plates are eventually going to pull apart. Here was the cartoon of the guyots and the seamounts. So guyot is a flat-topped undersea mountain, and a seamount is a pointy-topped undersea mountain, and an island is a seamount that at one point stuck out. We talked about these. This is kind of how a seamount kind of comes to be. It used to stick out, and then it eroded away, and then it eventually became an undersea mountain. We also talked about just things on the seafloor that you should know. These aseismic ridges. So a seismic ridge is caused by earthquakes. Aseismic ridges caused by hotspots. You can see the age getting older the further it is. So the hotspot's right here. This is the part of that's right over the hotspot. And I thought I had a slide of a hotspot, and here it is. Again, this is evidence, the youngest seafloor right over the hotspot, and then it gets older, 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 older. So the plate's moving this way, the hotspot's staying. There it is. And I said, you know, true, false. Most of the earthquakes are at plate boundaries, and that's true. True, false. All of the earthquakes and volcanoes are at plate boundaries, and that's false. So if I said some volcanoes are right in the middle of the plate, yep, some volcanoes are right in the middle of the plate, not at a plate boundary. So here's the plate boundaries. Here's subduction zone over here. Here's a trench and subduction and transform fault. But right in the middle of the Pacific plate, you have a hot spot with an island chain, and these are seamounts because they no longer are islands. They sunk down, so they're undersea mountains that do not come out of the water. And again, the youngest right over the hot spot, and all of these volcanoes are not active anymore compared to, let's say, where there's a trench with subduction going on. All of these are simultaneously active because this one Pacific plate is subducting underneath the Arctic plate. So you get a volcanic island arc compared to an island chain where only the most recent one is active. So island chain, island arc. Again, this might be a good thing to just kind of study. Should be able to know the names of these things, and you can see the outline of the plates. We talked about this a lot. But at the beginning of the class a month ago, when I said to you guys, does anybody know where the Mississippi River is, Amazon River, Alps, stuff like that on land, and everybody, Grand Canyon, everybody kind of more or less knew where everything was. Well, now you know a whole lot of things in the ocean. Remember, here's these ridges, mid-ocean ridges, you know where subduction zones and trenches are, you know where a lot of seamounts and guyots are over here in the western Pacific, you know where hot spots are, you know where island arcs are. Here's Indonesia, another island arc. You know where island chains are near hot spots. There's some abyssal areas, where it's kind of flat. You can see the abyssal areas. Like right here, the abyssal area. So all these things now transform fault, transform fault, transform fault. All these things you should be able to point to on a world map. And then just a review of the sediments, although you kind of have this from class, and then I did an earlier video. Terragenous, these are the kinds that come from land. So river runoff, dust, glacier rocks, and volcanic ash, and you've seen kind of all those slides already. And then you've got the biogenous. So you've got the two kinds of biogenous, the calcareous that come from creatures with calcium carbonate, and the siliceous that come from creatures with silica. You're not going to memorize any of these words, but you should be able to identify them if I use them in a multiple choice or true false. And remember that calcium carbonate dissolves when it gets really, really cold or really, really deep. So you only see these calcareous oozes, let's say, on the tops of seamounts or on the tops of ridges. So it kind of looks like snow because the calcium carbonate is white. And then we also learned about hydrogenous. So there's kind of two kinds that we talked about. One are these weird manganese nodules that no one totally understands. That just kind of dissolve out of the water. And then salt and gypsum are two other kinds of hydrogenous sediment that when the water evaporates, that's what's left. And then we also talked about cosmogenous sediment, everyone's favorite, the kind of so space dust landing on the seafloor all the time. But then during 65 million years ago, when an asteroid hit, there's a layer of these microtectites all around the seafloor, about 65 million years deep. Where after the asteroid hit, all this stuff was blown into outer space where it melted and cooled really quickly and then fell back down, and there's a history of it in the sediment record. And then the other thing about the sediment, your last piece of evidence that we talked about was that the sediment is thick far away from the spreading center. So where the seafloor is older, you get thicker sediment, and when the seafloor is younger, you get thinner sediment. So here, this blue area where there's almost no sediment right on the top of the ridges, and here the places farthest away, like these passive margins, is where you get the thickest sediment. And here's just another picture of where the different sediments are, which you've seen already. So that should be a pretty good review. Here's your study guide, just to see if we kind of covered everything. Let me just say this while I have the study guide up here. You're welcome to, if there's something on here that you don't know, my best recommendation is to send me an email. You can also, of course, look through what I recommend is watch all the videos, read all your notes. You're supposed to read the book. I'm not recommending that you memorize every word in the book, but certainly things that we've talked about in class and in these videos that I've assigned, if you want to get a better understanding of it, the book is fantastic for that. And there's also lots of images and pictures of things that we've talked about. So the book is a great tool for finding what we studied in class. Again, if you're still struggling or you feel like you don't know some of the things that we've talked about here, then the best thing to do is email me. And remember, I'm going to show up on Wednesday at 11:30 in my office hours, which is in the stockroom there, and you guys can come from 11:30 to 12 if you've got a noon class, or if you don't have a noon class, show up at 12 or 12:30, whatever, with your questions, and I'll just be kind of helping you with the test. And I'm just also going to say that I do give hard tests, so be forewarned. Although you do have basically, they're not hard if you study, and if you don't study, then they're really hard. So they kind of separate people who studied and separate people who didn't study. Okay, so I'm going to go out and have a good Saturday night, and you guys, you should do that too. Bye.